So welcome to this session on 3D transformation. So we'll discuss few things about 2D transformation, and we'll have few things to be discussed about 2D transformation as well. So in the previous session, we have what is meant by 2D transformation. So we have discussed 2D transformation. Also, we have transformations. So those types are translation, then we have discussed rotation, then we have scaling, then reflection and shear, right? So five types of transformations we have did. Now we will what we will do, we will have the 2D transformation concept, 2D transformation concept, or, and we will extend that 2D transformation concept to 3D transformation concept. Now, how to extend this? It is very easy to extend 2D transformation techniques to the 3D transformation techniques. Now, first of all, in case of 2D transformation, we know there is a first operation that is nothing but translation, right? Translation, translation. So, what is meant by translation in 2D transformation? So translation means shifting object from one place to other place in two dimension. And in case of two dimension, we are having only two axes. And in case of three dimension, we are having a three axis. So here we have only x and y axis, while in case of 3D we have x, y, and z axis, right? Three axis. So that in 2D transformation, the translation means nothing but shifting of object from one position to other position, and based on that we have matrix. So this is a basic we have discussed earlier. So 1 0 tx, right, 0 1 ty, 0 1 ty, then we have 0 0 1 0 0 1. So this is a matrix for translation. Then second matrix or second operation that we have discussed, it is nothing but rotation. So there is a rotation about some point in two dimensional plane, some plane rotation, rotation. Okay, so in case of rotation, the matrix is cos theta, then minus sine theta, 0 sine theta, cos theta, 0 0 0 1. So such type of matrix we know. Then third transformation we have as a scaling, right? Scaling means increasing or decreasing size of the object. And in case of scaling, we have matrix like this: sx 0 0 0 sy 0 0 0 1. So this is a matrix for scaling. Similarly, we know the reflection means finding mirror image of the object about any particular axis. And we have a shear means deformation in the shape. So those are the five different types of transformation that we have discussed earlier. Now, what is meant by transformation? Once again, we'll have the discussion. Transformation will change the object from one coordinates to other coordinates. Means it will change the coordinates. So that is nothing but a transformation. Now, in case of three dimension, we will extend the same concept ahead. Only thing is, only change is there are three axes like x, y, and z axis. So 3D transformation, there are different type of transformations like 3D translation, 3D rotation, 3D scaling, 3D reflection, and 3D shear. So five different types of transformation we have: translation, rotation, scaling, reflection, and shear. So in case of 3D translation, what we have to do, we will have a three axis, and we will continue the concept from two dimension. So if you are clear with the two dimensional concept, definitely you can understand the 3D transformations. So 2D will be definitely helpful for 3D transformation. So we'll begin with the first transformation, that is nothing but 3D translation. Now here you can see, suppose this is the object, first object we have, and the object is translated by some distance, tx in x direction, ty in y direction, and tz in z direction. So this is the new position of the object after translation. So this is a 3D translation. First of all, this is the first object, original object. This is the original object, and after taking tx, ty, and tz, it is shifted to some other location. So this is nothing but the new object, right? And there are the three parameters tx, ty, and tz in case of 3D translation. So 3D translation means what? It is nothing but a changing position of the object. It is the changing position of the object to the new position by distance. What distance now? Tx, ty, and tz. Now, what is the difference between 2D translation and 3D translation? There is one more parameter coming into picture, that is nothing but a TZ. So we will have the matrix. In case of 2D, the matrix is 3 by 3, right? 3 by 3. But in case of 3 dimension, the matrix will be 4 by 4, right? 4 by 4. Matrix will be 4 by 4. So this is the matrix you can see. Now what is the change? As this becomes 4 by 4, your last column will be having a parameters like a tx, ty, tz. So 1 0 0 tx, 0 1 0 ty, 0 0 1 tz, and 0 0 1 1. So this is a matrix for translation, 3D translation. Matrix for 3D translation. Now earlier for 2D translation, the matrix is like 1 0 tx 0 1 means only there are three spaces, and in case of 3D translation there are 4 by 4. This is a 4 by 4 matrix, right? 4 rows and 4 columns, 4 by 4 matrix. So 1 0 0 tx, 0 0 0 1 0 ty, 0 0 1 tz, and 0 0 0 1. So how many elements are there? Total 16 elements, and this is a 4 by 4 matrix. So I think you have understood what is a 3D translation. Translation means changing position of the object. It will change the position. You are taking an object, 3D object, from one place to other place. So that is called as 3D translation. Now, the same concept, next concept, we will relate with the 2D translation, 2D transformation, that is nothing but 3D rotation. Earlier, in case of rotation of 2D rotation, we are taking some axis and we are taking object, and that object will be rotated in the 2D plane, right? It is supposed rotated by angle theta in the 2D plane. But in case of 3D, the rotation happens about the axis. Rotation happens about the axis. So sometimes rotation may happen about x-axis, rotation may happen about y-axis, z-axis. So such type of rotation may happen. So that rotation, we can take the matrix of 2D rotation for finding the matrix for 3D rotation, finding the matrix for 3D rotation. Now here you can see this is a rotation about x-axis, this is rotation about y-axis, and this is a rotation about z-axis. So axis wise rotation you can do x-axis rotation, y-axis rotation, and z-axis rotation. Now first rotation will take, that is the z-axis rotation. Now here you can see, suppose this is the original object, this is the original object, and you are rotating about the z-axis, you are rotating about the z-axis. So this is a new object. Now in this case you will find that the z, as it is rotating about the z-axis, this doesn't change any coordinates of the z. It will not change any coordinates of the z if you rotate. What it will do, it here the coordinates of x and y will change. X and y will change. Hence the z remains. Suppose new z dash, if suppose it has x dash, x y z, okay, it has x y and z, and new object having suppose coordinate like x dash, y dash, and z dash. So in that case z will remain same, so z will remain as a z. Only x and y will change. X is equal to and y is equal to, it will change. So earlier in two-dimensional rotation, we have matrices, or we have the values or equation like x cos theta, x cos of theta, minus y sine of theta, y sine of theta, and about y it is x sine theta, x sine theta, and plus y cos theta, y cos theta. So this is the matrix, or this, those are the values we have: z dash, x dash, y dash. That is, z dash remains same as z, x dash remains as x cos theta minus y sine theta, and y dash will become x sine theta plus y cos theta. So we'll write in terms of matrix. How we can write it in terms of matrix? So this is the matrix we have, and now here you can see, whenever we have the matrix, what we can write? We will write like this: x dash, y dash, z dash 1 is equal to This is the multiplication of that x, y, z, and 1. Okay, so it will multiply cos theta with the x, y minus y sin theta with the y, and 0 with z, and this one with z. So finally here z dash will be z, and 1 will be 1. So x dash will be x cos theta, y sin theta. So this is a matrix we will get from the same concept of 2D rotation, whichever we have found out. Now next is 3D rotation about x-axis, and we will have rotation about z-axis. So if you keep in mind, whenever it will be like this x, y, and z, so you what you will do, you will change the equations or values, as x will be changed to y, y will be changed to z, z will be changed to x, as per your need. So whenever you want to find something, it will change accordingly. If suppose you are finding about x-axis, so x dash will remain same, x dash will remain same, but y dash and z dash will change. So y and z you will change accordingly. So here is the rotation about y-axis, rotation about y-axis. So this is the matrix for rotation about y-axis. So cos theta 0. So here y will be a unit, or y will be 1, and x and y will be cos theta and sin theta, minus sin theta, cos theta. Similarly, we have rotation about x-axis. So this is a rotation about x-axis. So 1 0 0 0 0 cos theta minus sin theta 0 0 sin theta cos theta 0 0 0 1. So this is once the same equation you can consider for considering x dash y dash. Same equation you can extend for 3D rotation about y-axis and 3D rotation about x-axis. So this is about the 3D rotation matrices. So you must remember all those matrices, and you must continue with this matrices. Now after 3D rotation, next concept is about 3D scaling. So in case of 2D scaling, we are having an object and we are increasing the size of the object, or we are decreasing the size of the object. And in case of 2D scaling, we have Sx as a one parameter and Sy as another parameter. So two parameters we have. And in case of 3D scaling, we are having a three axis as x, y, and z. We are having a three axis as x, y, and z. And because of that, you will increase your object in different direction. That may be in the x direction, y direction, and z direction, so that uh, the object size may increase or may decrease, so because for x-axis you will have sx as a what we can say the object, or sx is a parameter. For y-axis it is sy as a parameter, and z-axis it is sz as a parameter. So three parameters we have: sx, sy, and sz. So matrix in case of two dimension is, what is the matrix? Sx 0 0, then 0 sy 0 0 0 1. So this is nothing but the matrix for 2D scaling. So in case of 3D scaling, you can extend the same concept of scaling by adding one more row and one more column. So it will become sx 0 0 0 0 sy 0 0 0 0 sz 0 0 0 0 1. Now, as this is Sx, if you multiply with x, y, and z, multiply with x, y, z, and 1, what will be the answer you will get? X dash is equal to Sx into x, you will get. For y dash, it will be y dash is equal to Sy into y, and z dash is equal to, for z dash is equal to sz into z, sz into z. So those are nothing but the three things we have: sx multiplied by x, sy multiplied by y, sz multiplied by z. So three, what you can say, three s y, x, y, and z. It is multiplied by respective sx, sy, sz. Those are nothing but the scaling factors. You can scale by means, if you have scaling factor greater than 1, then your object size will increase, and if your scaling factors are less than 1, your size of the object will decrease. So that is the increasing and decreasing size based on the scaling factors sx, sy, and sz. Now once this 3D scaling is what we have discussion with the 3D scaling, we'll move towards next, that is nothing but 3D reflection. Reflection is nothing but the finding mirror image of the object, right? And in case of 3D, in case of two dimension, we are just reflecting object about the axis, object about axis. We can reflect about x axis, or we can reflect about y axis. But in case of 3D reflection, in case of 3D reflection, the reflection will happen about the plane, particular plane. Now here you can see this reflection is about xy plane. This is xy plane, so you can consider this as a mirror. So whenever you are finding the reflection about xy plane, so in that case the xy coordinate of the object will remain same, only there is a change in the z coordinate. So this is the suppose positive, the z will change to negative, z will change to negative, and if it is negative it will change to positive. So in case of reflection there are multiple types of reflection, like about xy plane, about xz plane and yz plane. So you can reflect about xz plane, xy plane or yz plane, and you will accordingly have the answers. So in case of xy plane the z coordinate only change, in case of xz plane only y coordinate will change, and in case of yz plane only x coordinate will change. So we will write one matrix. So this is a matrix for reflection about xy plane, and here only you will find the z coordinate will change from positive to negative, or if it is negative it will become positive, it will become positive. Now if you are taking xz plane reflection, okay, xz, so what will be the matrix you will have? The matrix for xz means y will be minus and remaining will be same, so this will become positive in this case, in which case about reflection about xz. Now if you consider if you consider yz plane reflection about yz, so x will change, so this will become minus and all other becomes plus. So this will become xz plane or yz plane, yz plane reflection about yz plane. So accordingly you have to write the values. It is not necessary to change all the values. In case of xy plane reflection only z value will change, and in case of xz plane the y value will change, and in yz plane it will change the x values. So in case of 3D reflection we have to consider the mirror image. In 2D also it is a mirror image, but while reflection it will reflect about what we can say plane, and in case of 2D reflection it will reflect about what, the line. It may be about x-axis, y-axis or any arbitrary axis. Here also there are the things reflection about arbitrary plane, but for that we have to use those concept, and we can find the resultant matrix. And final what you can say final transformation, 3D transformation, it is the 3D shear. So 3D shear, what is meant by shear? Shear means it is a deformation. Shear means it is a deformation of the object. Deformation of the object, it is called as shear. As example is given in the cyclone, the tree structure may be deformed because of the heavy wind. So that is called as deformation. Suppose somebody having the punch on the balloon, then the shape of the balloon may be deformed. So that is nothing but called as deformation of the object. So here it is xyz and this is object. The object may be deformed in x direction, y direction, z direction, and you can have the matrix like this: 1 0 a 0, 0 1 b 0, 0 0 1 0, 0 0 1. So here we have considered only xy, hence the deformation values are changing for x and y: 10a 01 b 001 001. So this is about the deformation of the object. So there are 5 transformations we have discussed. Like a translation means changing position of the object. The object, suppose this is a 3D object, in case of translation the object can change the position. And now 3D rotation, it can rotate about any axis, so rotation. Then scaling means changing size of the object. If suppose this is a 3D object, and if you are scaling up or scaling down, if you are scaling up the size may be increased, size may be increased. Now you have reflection, so reflection may happen about a plane. So here some object is there, after reflection object may be somewhere here. And shear means a deformation, the object may shape may be deformed. So such type of things may happen in the 3D shear. So this is all about the 3D transformations. So thank you for joining.